All right, let's begin the next lesson. In this lesson, we're going to start with a little review from the past where we're going to write an equation of a line. The first step whenever we're going to write the equation of a line is to find the slope. The slope, remember we use the letter m, and then we use the formula y2 minus y1 over x2 minus x1. So we are going to have to find two different x's and two different y's. I am choosing these two right here because they are both positive, so they look good to me. This is the first x, this is the second x, this is the first y, this is the second y. So now let's plug into the formula. y2 would be 17, minus y1 is 14, x2 would be 1, and x1 is 0. Now let's see what this would be. 17 minus 14 over 1 minus 0 is equal to 3. So my slope is 3. Okay, so now I need to find my y equals mx plus b. So let's find a y and an x I know. Let's use these two right here. So I know that my y here is 17, my m is 3, x is 1 plus b. So I would have 17 equals 3 plus b. To get rid of 3, I subtract 3. And 14 equals b. So we would end up having y equals the m is 3, x plus 14. Another way you could find the y-intercept is if you know that a y-intercept is always when x equals 0. Right here we would know that our y-intercept was 14. And we can double check that this is correct by going to our graphing feature. Let's type in the equation. 3x plus 14, enter. Let's go look at the table and make sure we have the same numbers, 0 and 14, 1 and 17, 2 and 20. That looks good. Alrighty, so now today we are going to be able to distinguish between linear and exponential functions, and then we're going to be able to write equations and find their rate of change. So notice what do you notice? What do you notice about both of these graphs, and what do you wonder? Well, here I notice that this one's a straight line going up. Straight line going up. And I realize that this is also going up, but in a curved shape. So I see that things that are the same are they're both going up, but what I notice is different is one's a straight line and one is going up but in a curve. And now what do I notice about these tables? Well, to get to 5, from 5 to 9, I could add 4. To get from 9 to 13, I could also add 4. 13 to 17, I could add 4. 17 to 21, I could add 4. Okay, if I didn't know that, I could also take the second number, which is 9, subtract it from the first number, 4. Take the third number, subtract it from the second number, 4. Take the fourth number, subtract it from the third number, still get 4. Alright, let's look at this next one. How do I get from 3 to 9? I could add 6. How do I get from 27 to 9? 27 minus 9. I could add 18. To get from 27 to 81. 81 minus 2017, I would have to add 54. Alright, I'm realizing that these are not the same numbers. What if I tried to multiply? How do I get from 3 to 9? 3 times 3 equals 9. 9 to 27? Oh, I would also multiply by 3. 27 times 3, does that give us 81? That does. Oh, so I noticed that this one is adding, and I noticed that this one is multiplying. They both have the same x's, they're going up by the same value, but how you get from one number to the next is different. So these are called linear and exponential. Straight lines, straight horizontal lines. Also, it could be vertical or horizontal, but straight lines that go up or down at a constant rate is called linear. That's when you're adding or subtracting the same number to get from one thing to the next. We like to think of that we're always adding a number. Maybe we're adding a positive number or we're adding a negative number. And an exponential function is one that's either increasing or decreasing, but it's happening at such a fast rate that it makes this curved shape. What are the forms of equations? Linear equations are these normal ones that we're used to, y equals mx plus b. Where exponential functions are where you're multiplying and you're raising something to an exponent. Alright, let's look at these. We want to determine if these are linear, exponential, or neither. So let's look at the first one. 5 to 7, I add 2. 7 to 9, add 2. Meaning it's linear. If I'm adding the same number, it's linear. Let's see, 3 to 6, I would add 3. 6 to 12, I would add 6, so that is not linear. Let's see if it's exponential. What would I have to multiply to get from 3 to 6? I would have to multiply 2. 6 times 2, does that give me 12? It does, and 12 times 2 does give me 24, making this one exponential. And let's see this one. 8 to 9, I add 1. 9 to 11, I add 2. 11 to 15, I add 4. Not linear. Let's see exponential. I don't know what I would multiply by to get from 8 to 9. So let me try dividing. 9 divided by 8. I would have to multiply by 1.125. 11 to 9. I would have to multiply by 1.2222. So it's not the same. So it's not exponential, so it's an other one. And now try this one. This one's talking about more real life stuff, hours and money, but it doesn't matter. Alright, to get from 100 to 200, I would add 100. 200 to 400, I would add 200. So it's not going to be linear because I'm not adding the same thing. To get from 100 to 200, I would multiply by 2. 200 to 400, multiply by 2, making it exponential. Let's look at the next one. 100 to 200, I would add 100. 200 to 300, I would add 100. Oh, but 300 to 200, I would add a negative 100. So it's not linear, and it's not going to be exponential because I can't go up and then start going down again, so it's another one. And let's look at this last one. 100 to 250 is add 150. 250 to 400, add 150. And the pattern continues, making it linear because we're adding the same number. Alrighty. So now we want to find equations on a calculator. To find equations on a calculator, we can use our fancy little calculator that we have, and we can go home on our calculator. We would click the fourth icon, which is the list and spreadsheets. We then go to A, where it says A, and we're going to label it X. We go to B and we label it Y. Then we list all the numbers that were given in the table. And then we're going to go to Stats, Stat Calculation, and we're going to click Linear Exponential. And then we will choose X and Y from the drop-down menu and then write the components of our equation. What am I talking about? So, let's look at this one. First, let's determine, is this linear or exponential? To get from 3 to 6, I would add 3. To get from 6 to 12, I would add 6. And to get from 12 to 24, I would add 12. So this is going to be exponential. So we're going to have to find the equation of this using what we just learned. So let's go do that. Alright, so now that we know that it's exponential, this is what we do on the calculator. You want to start by going to List and Spreadsheets number 4. You're going to X out of what's ever there, say that you do not want to save it. Then go back to the fourth icon, which is List and Spreadsheets. Click OK. Go up to A, make it say X, click Enter. Then go down to number 1, type in 0, 1, 2, 3. I'm just copying my table. Now go over to B, make it say Y, because f of x means the same thing as y. Click Enter, and type that stuff in. 3, 6, 12, 24. Click Enter. Then click Menu, number 4, which is Statistics, number 1, and then we're going down to A for exponential since we just found this is exponential. Where it says X list, you're going to make that say X. Where it says Y list, you're going to make that say Y. You're then going to click OK. And this is how we are going to write our final equation. So, the equation for an exponential, it tells us right there that the equation for exponential is y equals a times b raised to the x power. That little triangle thing means exponent. Now, they told me that a equals 3, and b equals 2. So I'm just going to plug in what I know. I know that it's y equals a, which is 3, times b, which is 2, raised to the x. And that would be how I write my equation there. Now let's go to this next one. This would be the equation of the line right here. All right, let's see. To get from 5 to 7, I add 2. 7 to 9, I add 2. 9 to 11, I add 2. Okay, good. So now let's see how we would type this in our calculator. Go to list and spreadsheets. We are going to X out of whatever's already put in. Do we want to save it? No, we do not. Then we are going to go to list and spreadsheets, click X, then type in what we have for the X numbers, then Y, and then 0, enter 1, 2, 3, and then go over and type in the Y, 5, 7, 9, 11, enter. Then we click menu, statistics, stat calc, and we go to linear regression because we found that it was linear since we're adding by the same number. Make X list and Y list, say X and Y, then click OK. And right there, they told me that my linear regression equation is y equals mx plus b, which we should already know. They're telling me my y is 2, my m is 2, so 2x, and my b is 5 plus 5. And that makes sense because your b is whatever number you start at, 0 is starting at 5, and then our m is our slope, which is how much we're going up by, and in this equation, we are going up by 2. All right, that is how we write equations. We are going to do more practice with that tomorrow. For now, we are going to look into the average rate of change. So, change. What is the average rate of change? It's simply the slope of a line joining 2 points on a given graph of a function. Here is a model question. It says, find the average rate of change of f of x equals 2 raised to the x power between x equals 3 and x equals 4. All you're going to do is take this function that you are given, 2 raised to the x power, and plug in 3 as an exponent and plug in 8 as an exponent and find what those are equal to. So now you have the ordered pairs that when you plugged in 3, you got 8. When you plugged in 8, you got 256. Now we could use these and label them x1, y1, x2, y2. And we could use the slope formula, plug in what we know, and we get 49.6 as a decimal. When you're talking about slope, you usually leave it as a fraction, but average rate of change, most of the time we leave it as a decimal. So let's actually practice this. Let me get my calculator. All right, let's practice this. So, find the average rate of change of this function from x equals 2 to x equals 7. So for x equals 2, in my function, wherever I see x, I'm just going to put 2. And for x equals 7, in my function, wherever I see x, I'm going to put 7. Let's type this in, 3 parentheses 2 raised to the second power, and then we have 2 raised to the 7 power. So this would be 12, and this would be 384. So when x equals 2, out we get 12. When x equals 7, out we get 384. So now we could label them x1, y1, x2, y2. And let's make this into our formula, y2 minus y1 over x2 minus x1. y2 is 384 minus y1, which is 12. x2 is 7 minus x1, which is 2. Alright, let's make this into a fraction. 384 minus 12 over 7 minus 2, and we get 74.4 is our average rate of change. Nice job. Let's look at the next one. Find the average rate of change of this from x equals 3 to x equals 9. So in my function, anywhere I see x, I'm just going to replace this one with 3 and this one with 9. And let's type this into the calculator. 3 times 3 minus 2, and then 3 times 9 minus 2. So we would get 7 and 25. So one point would be 3 comma 7, and the other point would be 9 comma 25. So now we have y2 minus y1 over x2 minus x1. If it makes your life easier, you can label these points. So we can label them x1, y1, x2, y2. So we would get 25 minus 7 over 9 minus 3. And let's see what this gets us. 25 minus 7 over 9 minus 3. We get the average rate of change is 3. Nice job. And that wraps up our lesson on finding the average rate of change and finding equations. Good job, good job.